Hello everyone. In this video I will be explaining about differentiation rules of some of the functions. Let's first talk about what differentiation is. It's the known form of derivative. A derivative is a rate of change of a function with respect to a variable. We can also say derivative is described as either rate of change of a function or slope of the tangent line at a particular point on the function. So we will be talking about slope and tangent line and stuff in the following topics. So in this topic, we will be just talking about the rules, differentiation rules. So first of all, we should know how derivative is denoted. It's denoted as f prime of x, since it's the slope of a function at a particular point. Slope is change in y over change in x, so we can write this as dy over dx instead of delta y over delta x. And it's the same as df over dx, df of x over dx, y prime, f prime of x. These are all how we can express denote derivative. So let's start with the first rule. The first rule, differentiation, is the constant rule. Whenever the function is constant, its derivative is 0. Let's take a look at the following examples. F of x equals 8, 0, negative 3, negative 1 over 4. Those are all numbers, constant numbers. Similarly, pi, pi squared, e cubed, they are also numbers. Their powers are also numbers. Ln 7, it is a number. When you type this in the calculator, it will give you a decimal answer. Sine pi, it's also a number. It's not a function, it's a number. It has a value. Square root of 5. So they're all numbers. They're all constants. So we can say derivative of the function, derivative of all these functions is 0 because the functions are constant. This is the first rule. Let's continue with the second rule, power rule. The power rule says, in order to take the derivative, take the power, put it in front of the function, and decrease the power by 1. So pull the power out in front and decrease the power by 1. For example, x to the 6. 6 is the exponent. Move it out in front. It's 6, x to the power of, decrease the power by 1. 6 minus 1 is 5. Similarly, 1 over x to the 7. In order to apply power rule, our function should be written in the numerator. The variable should be written in the numerator. So the first thing we need to do before taking derivative is rewriting the function. So your function is, first of all, when you rewrite it, x to the power of minus 7. Because remember, when you move your variable in numerator or in denominator, when there is a change, when there is a movement, then you should change the sign of the exponent. The exponent was 7 in denominator, it becomes minus 7 in numerator. So that's the rewritten form of the function. So in this new form, you take the derivative. F prime of x equals, according to rule, take the power out in front, move it out in front, negative 7, x to the power of, decrease the power by 1, negative 7 minus 1, negative 7 minus 1, negative 8. Okay, that's it. That's how we take the derivative and we simplify. Again, you move the variable in the denominator to avoid negative exponents. So it's negative 7 over x to the 8, the simplest form. All right. So we may have fractions, so we should move the variable in numerator. We may have radicals as well, so we should turn the radicals into fractional exponent form. So this function is equivalent to x to the power of 1 over 5, because remember, the power of the inside will be written as the numerator, power outside, power in the outside, the index should be written as a denominator. So you should write this radical as fractional exponent. So this is how you transform your function into fractional exponent. Now we can take the derivative. So f prime of x equals, okay, we take the power out in front, 1 over 5, x to the power of 1 over 5 minus 1. So you decrease the power by 1. You should equalize denominators to do so. This is 1. So 5, 1, they are unlike. To make them same, multiply the second one, top and bottom, by 5. So 1 minus 5, negative 4. So it becomes 1 over 5x to the power of negative 4 over 5. So as in the previous question, we have a negative exponent. So to get rid of the negative exponent, we should move it down. Move the variable down. So the exponent becomes 4 over 5. This is my answer. If you cannot see this answer in the options, let's say your options are radicals, you can turn this into radical again. It's 1 over 5. So in radical, remember, the numerator gives you the inside exponent, denominator will give you the index outside exponent, let's say. So this or this, they are same, they are equivalent, so one of them will appear in the options. Okay, let's move on. Okay, we may have variables at the top, variable at the bottom. So for these kind of questions, we should rewrite the function so that we have only one variable written in the numerator. Okay, so let's get rid of this radical first. So what is square root of x in terms of fractional exponent? It's x to the power of, inside power is 1, outside power the index is 2. So it's x to the power of half divided by x. Now write it as a single variable. Remember another rule: when we have the same basis, we subtract the exponent in division. So 1 over 2 minus 1, negative 1 over 2. So that's my function rewritten in different way so that I can take derivative. Now I can take derivative. I'm ready. F prime of x equals, take the power out in front, negative 1 over 2, and decrease the power by 1, negative 1 over 2 minus 1. Negative 1 over 2 minus 1 is negative 3 over 2. So that's my answer. Not written in simplest form, of course. We should simplify it. Negative exponent, to make it positive, you move the variable in denominator. So that's one of the answers. We can, of course, continue rewriting this answer. We can write this as radical. 2 is the inside, 3 is the inside power, 2 is the outside, so it's square root of x cubed. Also, I can take x squared out as x. So that's also another way of rewriting this function. So those are all the results. So whatever you have in options will be your answer. So taking derivative is easy when you know the rules. You take derivative in one step. The rest is all about simplification, algebra, basic math. Alright, so here we have maybe 1, 2, 3, 4 different versions, 4 different answers. They're all same, they're all equivalent, but there are many ways of writing the function. Okay, as we talked in the previous questions, when there is negative exponent, we can change the location. When there is radical, we write this as fractional exponent. When there is division with the same basis, you subtract the exponents. When there is multiplication with the same basis, you add the exponents. So these are from previous grades. We are still using it. Okay, next rule, constant multiple rule. So whenever we have constant in front of the function, you keep the constant and just take the derivative of the function. Keep the constant, take derivative of the function. 1 over 5, for example, in this question is the constant. Keep it and take derivative of the function with variable. X to the 5. 5 is the power, move the power down in front. X to the power of, decrease the power by 1. So 5 will cancel. X to the 4 will be f prime. All right, pretty simple. Next question. Pi is a coefficient. We have another coefficient here if we rewrite the function. F of x equals pi divided by 3x squared is 9x squared actually. So here I see pi over 9 as a coefficient. So I can keep pi over 9 out in front and rewrite x squared. X squared, the variable is in denominator. I cannot take derivative if it's in the denominator by using power rule. So I should move it up. When I move it up, it's x to the power of minus 2. Exponent changes. Now, keep the coefficient when you take the derivative. It's pi over 9 staying in front. Now take the derivative of x to the minus 2, which is minus 2 being pulled out in front times x to the power of minus 2 minus 1. Decrease the power by 1 makes minus 3. So it's negative 2 pi over 9 x to the negative 3. We have negative exponent. Let's get rid of that negative by putting it down in denominator. So negative 2 pi over 9x cubed is the final answer, the simplest form. Alright, let's keep solving different kind of questions for different functions. So the next rule, sum and difference rules. So when there's addition or subtraction, we take derivative of each function separately and add the result. For example, pretty simple. You take derivative of each term one by one. That's it. F prime of x equals derivative of 2x cubed. 3 is the power, move it down in front. So 2 multiplied by 3 multiplied by x to the power of 3 decreased by 1 makes 2 minus x squared. 2 is the power, move it down in front. 2x plus 3x. The derivative is 3 because the power is 1. When you decrease the power by 1, it becomes x to the 0, which is 1. So derivative is, you can say directly 3. So the result is 2 times 3, 6x squared minus 2x plus 3. Idea is pretty simple. Okay, next question. T squared easy. 2 is the exponent. Pull it down in front. So it is 2t minus, what about 4 over t cubed? Like the previous questions, the variable is in denominator, move it in the numerator to use power rule. So rewrite it as 4t to the power of minus 3. Now you can take its derivative. So negative 3 times negative 4, 12 t to the power of negative 3 minus 1, negative 4. So I pulled the power out in front. Negative 3 by negative 4 becomes 12. And I decreased the exponent by 2, by 1, it becomes minus 4. So it is 2t plus 12 over, when you get rid of the negative power, t to the 4. Okay, that's the final answer, simplest form. What about for division? Let's say the function is divided by something. So we will study quotient rule in the following rules, but it is not necessary here. We can still apply power rule by by rewriting the function first. Let's rewrite the function. So remember, if there is a plus b over c, then you can separate this fraction. You can write this as two fractions, a over c plus b over c. C is the common denominator here. Similarly, x squared is the common denominator for all of the terms in the numerator. So we can rewrite this as x cubed over x squared minus 3x squared over x squared plus 4 over x squared. So there's simplification, of course. We will have x minus 3 plus 4 over x squared. To apply power rule, remember, move x squared up to numerator for x to the minus 2. Now we can apply derivative. After we get our function in simplest form, we can apply derivative. So the derivative of x is 1, derivative of 3 is 0, derivative of 4x to the minus 2, minus 2 being pulled out in front, minus 2 times 4 minus 8, x to the negative 2 minus 1, negative 3. When you rewrite the result, negative 8 divided by x cubed. Alright, so that's the answer. Okay, another question involving radical. They're all in the book. They're all exercise questions. Let's distribute square root of x first. Write it as a single variable. Get rid of that multiplication. So f of x is, first of all, we can consider square root of x as x to the half, right? We can rewrite this as fractional exponent. So x to the power of 2, remember, if we have the same basis, we add exponents, plus x to the half times 4, 4x to the half. So this one is x to the 2 plus half, 5 over 2 plus 4x to the half. So now I just got my function written in simplest form. Now it's time to take derivative. So taking derivative is the last step if our function is not simple. We simplify it first. So now we can take derivative. Power comes out in front, 5 over 2. The exponent decreases by 1, 5 over 2 minus 1, 3 over 2, plus exponent comes out in front, 1 over 2 times 4, 2, x to the power of. The exponent will decrease by 1, 1 over 2 minus 1, minus 1 over 2. Okay, that's the answer. To get rid of that minus exponent, we rewrite this as 5 over 2x to the 3 over 2 plus 2 over x to the 1 over 2. We can still continue rewriting this. How? We can turn them into radical, right? They're fractional exponents. We can turn them into radicals as 5 over 2 x to the power of 3 under square root, right? The inside power is 3, outside power is 2, which means we have square root, plus 2 over x to the power of 1 is the inside, 2 is the outside, so another square root. Okay, and I can still rewrite it because I have x cubed inside x cubed. I have x squared, which can be taken out of radical as x. So 5x square root of x over 2 plus 2 over square root of x. Okay, this is not the only answer. This is not the only answer. We have many answers. This can appear in the options. This can appear in the options. This. We don't know what will be the answer in the options. So depending on the option, you'll continue manipulating your answer. So the first step only is about taking the derivative. After we simplify the function, we took derivative. We are done with the derivative. The rest is all about algebra. We just manipulate the answer according to the options. All right. Okay, let's continue with another rule. Okay, the chain rule for power functions. So we already studied the power rule. We bring down the power in front, decrease the power by 1. This is the rule. But what if our base is not just x? If our base is not just x, it is much more complicated. Then we also should take the derivative of this base and multiply it by the result. Okay, if there is just x to the n, we bring the n down in front, decrease the power by 1. That's it, we are done. But if the base is not just x, it is complicated, Then we take also derivative of the base multiplied by the result. Here we can also do the same. Derivative of x is 1. That's why we don't write 1. It has no effect. But if it is different, we have to write it. For example, let's take a look at this exercise question. Okay, bring the exponent down in front first. 4 multiplied by 6x minus 5 to the power of, decrease the power by 1, 3. And I'm not done, since my base is not that simple. We multiply the answer by the derivative of the base. What is derivative of the base? Derivative of 6x is 6, 5 is 0, so it's just 6. Now, let's simplify. 4 by 6, 24, 6x minus 5 to the power of 3. This is our f prime. Alright, so same idea in the following question. We have 4 as an exponent, move it down in front. So 3 multiplied by 4 multiplied by 4 minus 9x to the power of, decrease the power by 1, which makes 3, times derivative of the inside. Derivative of 4 is 0, negative 9x is negative 9. Let's simplify. 3 times 4, 12. 12 times negative 9. 4 minus 9x cubed. So negative 108 in a bracket. 4 minus 9x cubed is the answer. Okay. Okay, let's move on with square root function rule. So what's the derivative of a square root? So in the previous questions, we rewrote square root as a fractional exponent. It's equivalent to 1 over 2, right? It is a way we can apply this. But if our radicand is not that simple, it's complicated, then this won't work. We'll need more complicated rule. So the rule is, for square root function, if we don't have that simple radicand, we apply the rule as it's given as u prime, derivative of the inside, divided by 2 square root of u. Derivative of the radicand divided by 2 square root of the radicand. Okay. Square root of x. Either use the previous method, turn it into fractional exponent, apply power rule, move 1 over 2 out in front, decrease the power by 1, 1 over 2 minus 1, negative 1 over 2, and since the power is negative, move it down to make the power positive, and then let's turn this fractional exponent into radical. So x to the 1 over 2 is square root of x. So that's what I get if I apply power rule. If I apply the rule that's given here, derivative of the inside, derivative of x is 1, divided by 2 square root of x. Just one step. If I know the rule, it's much more easier, as you can see. Okay? Instead of doing this, rewriting the function, taking the derivative, simplifying and stuff, in one step I can answer the question. Okay, another example. 1 minus t under radical. So f prime will be derivative of inside, negative t, derivative of negative t is negative 1, divided by 2 square root of the same radicand, 1 minus t. So in the denominator, you don't change the radicand. Whatever you have on the root, you'll write it. Question 15. Imagine you are using this by the first way, by turning it into a fractional exponent and using power rule. You won't go anywhere. But by using this rule, you'll solve it easily. Derivative of inside, derivative of x squared is 2x, minus derivative of 3x is 3, divided by 2 square root of same function. That's it. No simplification. We leave it as it is. Okay, when we solve questions, we take the given, we rewrite the given and differentiate and then simplify. So this is only about calculus derivative. The rest is all about simplification, algebra, basic math, whatever you call it. Okay, I'll explain this rule and finish this video. Okay, the last rule for this video is chain rule for natural logarithmic functions. So if you have ln, natural logarithmic function, its derivative is pretty simple. It's derivative of u divided by u. Derivative of the angle divided by the angle. Pretty simple. Ln x. So x is the angle. Derivative prime of x is derivative of x, which is 1, divided by itself, 1 over x. See? So simple. So here, what's the angle? Our angle is x squared. So we take in the numerator, we write the derivative of the angle, which is x squared. The derivative of the angle, which is 2x, itself is x squared. So there's simplification, of course. X and x will go. So the result is 2 over x. All right. Ln square root of x, derivative of the angle, f prime of x, derivative of square root of x is 1 over 2 square root of x by the new rule, divided by itself, square root of x. Now, how can I rewrite this? How can I simplify this? I take the numerator, 1 over 2 root of x, multiply it by reciprocal of denominator, 1 over root of x. So it is 1 over 2 square root of x times square root of x, x. Okay, 1 over 2x. Okay, let me at least finish exponential function 2. We don't have much left. So exponential functions, e to the u, its derivative is derivative of the exponent multiplied by itself. Derivative of exponent multiplied by itself. E to the x, f prime is derivative of the exponent, which is 1, multiplied by itself. So it's just e to the x. Derivative of e to the x is itself. What about next one? Exponent is negative x squared. We take its derivative, which is negative 2x, multiply it by itself, original function. Okay, they are pretty simple. Differentiation rules are pretty simple. Okay, here we have natural logarithmic function. Inside the natural logarithmic function, we have exponential function. Nothing changes. You just apply the rule, whatever you know about ln. We just learned that it's derivative of the angle divided by itself. So, what is derivative of the angle? What is derivative of e to the x? We just learned that derivative of natural logarithm, derivative of exponential functions is derivative of the power multiplied by itself. So, derivative of the angle divided by the angle itself, right? This is the derivative of natural logarithmic function. So derivative of exponential function is derivative of the power, which is 1, multiplied by itself. So e to the x. E to the x over e to the x is 1. Okay, that's it. Okay, next and final question. This time is final. Derivative of the angle divided by itself, divided by the angle, the derivative of natural logarithmic function. So 1 plus e to the x derivative divided by the angle itself. Derivative of 1 plus e to the x is e to the x, because in the second rule, in the exponential rule, derivative of e to the x, we just got it as itself, so it's e to the x over 1 plus e to the x. So no simplification, this is written in simplest form. So for now we are done. So in the next video I'll continue explaining the rest of the differentiation rules.